Chapter 17, EDI or IDOC Deep Dive for SD91, Difference between EDI and IDOC in SAP terms. Core conceptual distinction. To answer this effectively in an interview, you must distinguish between the method of communication and the format of the data. EDI, Electronic Data Interchange, is the overarching concept and industry standard for the intercompany exchange of business documents in a structured format. It refers to the external transmission of data between trading partners, such as a customer sending a purchase order to a vendor. EDI is system agnostic. It does not care if the sender uses SAP and the receiver uses Oracle. Common EDI standards include ANSI X12, used primarily in the US, and EDIFACT, used globally or Europe. The role of the IDOC, intermediate document. In contrast, an IDOC, intermediate document, is an SAP proprietary data container file format used to store and exchange data between SAP systems or between an SAP system and a non-SAP system. The IDOC is the technical vehicle that SAP uses to interpret the EDI message. The translation process. The relationship works as follows. 1. External layer. The trading partner sends an EDI file, example, an EDIFACT orders message. 2. Middleware layer, an EDI subsystem like Sterling, Gentran, or SAP PO or PI receives this file. The middleware translates the EDI standard format into the SAP IDOC format, example, ORDERS05. 3. Internal layer, the IDOC is posted into the SAP system. Key interview nuance. An 8-year consultant should note that IDOCs are not exclusively for EDI. They are also used for ALE, application link enabling, to transfer data between distributed SAP systems. Example, sending material master data from an ERP system to an EWM system. Therefore, while all EDI in SAP typically utilizes IDOCs, not all IDOCs are used for EDI. Technical structure. EDI, defined by standards bodies, UN or EDIFACT, ANSI. IDOC, defined by SAP structure, consisting of the control record, EDIDC, data records, EDID4, and status records, EDIDS. 92. Common SD IDOCs used, orders, DESADV-INVOIC. 1. Orders, sales order or purchase order. Message type, orders. Basic type, ORDERS05, commonly used version. Usage, in SD, this is primarily an inbound IDOC. A customer sends a purchase order via EDI, which enters SAP as an inbound IDOC to create a sales order, VA01. Key segments, E1 EDK01, header data, currency, org data. E1 EDK14, organizational data, sales org, dist channel. E1 EDP01, item data, material number, quantity, UOM. E1 EDP19, object identification, customer material number mapping. 2. ORDRSP, order response. Message type, ORDRSP. Usage, this is an outbound IDOC sent from the vendor, U, back to the customer to confirm that the order has been received and processed. It acts as a digital order acknowledgement, BA00 output. 3. DESADV, dispatch advice or ASN. Message type, DESADV. Basic type, DELVRY03 or DELVRY07. Usage, this is an outbound IDOC in SD. When the outbound delivery is PGID, post-goods issue. This IDOC is triggered to inform the customer that goods are on the way. It is often referred to as an ASN, Advanced Shipping Notice. Key segments, E1 EDL20, delivery header. E1 EDL24, delivery items, batch, packaging. E1EDL37 or E1EDL44, handling unit or packaging data, critical for warehouse integration. 4. INVOIC, invoice. Message type, INVOIC. Basic type, INVOIC02. Usage. This is an outbound IDOC in SD. It transmits the billing document data to the customer so they can process the payment. Key segments, E1EDK01, invoice header, terms of payment. E1EDP01, invoice items, net value, tax details. E1EDP04, tax details per item. 93. Real issue inbound sales order IDOC failed, how you debug. Initial assessment, the what. When an inbound order's IDOC fails, the first step is to check the status in transaction WE02 or WE05. You will typically see a red light with a status code, most likely status 51, application document not posted. Analysis steps, the why. 1. Examine status records. Expand the status record in WE02 to read the specific error message. Example: material XXX, not defined in sales org YYY or customer ZZZ blocked. 2. Check data segments. Review the data records within the IDOC to ensure the incoming data matches the master data in SAP. For example, check segment E1EDP01 to see if the customer sent a valid material number or a customer-specific material number that requires an info record map. Debugging process, the how. If the error message is generic, example, error during processing, you must debug 1. Transaction WE19, test tool. Open the failed IDOC number in WE19. This transaction allows you to edit and reprocess the IDOC for testing. 2. Function module identification. You need to know the process code handling this IDOC, usually found in the partner profile WE20. For orders, the function module is typically IDOCINPUTORDERS. 3. Setting breakpoints. Open SE37, enter IDOCINPUTORDERS, and set a breakpoint. Alternatively, simply use the Inbound Function Module button in WE19. 4. Foreground mode. In WE19, click Standard Inbound. A pop-up appears. Check the box. Call in debugging mode or select foreground processing. 5. Execution. The system will launch the ABAP debugger. You can now step through the code, F5 or F6, to see exactly where the BDC, Batch Data Communication, or BAPI fails. 6. Common findings. You might find that a specific field is missing in the IDOC that is mandatory in your specific sales order configuration. Example: Incoterms or payment terms were not mapped. Resolution. Once the data gap is identified, you have 2 fixes: master data fix, correct the customer, or material master data in SAP. Mapping fix. Contact the middleware team to map the missing field in the transformation logic if the customer is sending it, but it's not populating the IDOC segment. 94. Difference between status 51 and 53. Status 51. Error. Application document not posted. Definition. This indicates a functional failure during the processing of an inbound IDOC. The technical transmission was successful. The IDOC exists in SAP, but the business logic failed to create the document. Example: sales order. Causes: master data issues, customer blocked, material not found. Configuration checks: credit limit exceeded, mandatory fields missing. Or logic errors. Action: requires manual intervention. A functional consultant or support user must analyze the error in WE02, fix the underlying data issue, and reprocess the IDOC using program RBDMANI2 or transaction BD87. Status 53. Success application document posted. Definition. This indicates that the inbound IDOC was processed successfully and the application document, example, sales order, has been created and saved in the database. Validation. In WE02, the status record for 53 will usually contain the document number of the object created. Example: standard order 12,345 has been saved. Action: no action required. The process is complete. Context for interview, mentioning that status 64, ready to be processed, usually precedes these, is helpful. If an IDOC is stuck in 64, the background job, program RBDAPP01, has not picked it up yet. Status 51 and 53 are the final outcomes of the processing attempt. 95. How partner profiles affect SD IDOC processing. The gatekeeper of EDI. Transaction WE20, partner profiles, is the central configuration that dictates who we can exchange data with and how that data is processed. Without a configured partner profile, SAP will reject any incoming IDOC and fail to generate any outbound IDOC. Key components in WE21. Partner number and type. You define the partner. Example: customer 1000 and the partner type. KU for customer, LI for vendor, LS for logical system. 2. Inbound parameters, incoming data. Here you define which message types. Example: orders. This partner is allowed to send. Process code. This links the message type to the specific function module that processes the data. Example: process code ORDE links to IDOCINPUTORDERS. Processing mode, you choose trigger immediately, process instantly, or trigger by background program batch processing. High-volume environments usually prefer background processing to manage system load. 3. Outbound parameters, outgoing data. Here you define which message types. Example: ORDRSP, INVOIC. We can send to this partner. Receiver port defines the technical destination. Example: the RFC link to the middleware. Basic type specifies the IDOC structure version. Example: ORDERS05. Message control. This is the critical link between SD output determination, NACE, and IDOCs. You map the application, V1, output type, BA00, and process code, ORDE. This tells SAP when output BA00 is triggered for this customer, generate an IDOC. Interview impact. If a user complains that an IDOC wasn't generated despite the output type turning green, the first place to check is the outbound parameters in WE20 to ensure the message control entry exists for that output type 96. How output type triggers IDOC generation. The link, message control. In SAP SD, IDOCs are rarely created manually. They are triggered by the output determination mechanism, condition technique. The process flow. 1. Transaction. Example: VA01 or VF01. You save a sales order or billing document. 2. Output determination procedure. SAP checks the procedure assigned to the document header. 3. Condition records. NACE or VV11 or VV31. The system looks for a valid condition record for the output type. Example: BA00 for order confirmation or RD00 for invoice. 4. Medium 6, EDI. The condition record must have the transmission medium set to 6, EDI. 5. Partner function. The partner function. Example: SP sold to in the output record determines who receives the IDOC. Technical execution. RSNAST00. When the document is saved, an entry is created in table NAST. If the dispatch time is set to 4, send immediately. The system immediately checks the partner profile, WE20. It looks at the message control tab in WE20 for that partner. It matches the application, V1, output type, BA00, and change message indicator. If a match is found, it uses the outbound process code defined there to fill the IDOC segments and pass it to the port. If dispatch time is 1, send with periodically scheduled job. The program RSNAST00 must be scheduled to process the NAST entry and trigger the IDOC. 97. Where you check IDOC errors in production, primary tool WE02 or WE05 IDOC list. These are the standard transactions to view lists of IDOCs. Filter strategy, in production, volume is high. You never run WE02 wide open. You filter by, date, or time, created on. Message type, example. Orders, INVOIC. Status, specifically status 51, inbound error, or 29, outbound error. Business-friendly tool, WLFIDOC. This is a newer, more user-friendly IDOC monitor that allows for better filtering and display customization compared to the classic WE02. Monitoring tools, Solution Manager. In large landscapes, consultants often rely on Solution Manager, Solman, alerting. Instead of manually checking WE02, Solman monitors the table EDIDC for status 51 and sends an email alert to the support team. BD87 Status Monitor. Used not just for checking, but for aggregated viewing and reprocessing. It groups errors by message type and error code, allowing you to see patterns. Example, 50 IDOCs failed with the same material missing error. 98. Change pointers when and why they are used. Core concept, change pointers are a mechanism in SAP to track changes to master data, customer, material, pricing, and distribute those changes to external systems automatically. They are the backbone of master data distribution, ALE. Why they are used? Imagine you have an SAP ERP system and a separate SAP EWM warehouse system. If you create a new material in ERP, EWM needs to know about it. You don't want to manually send the full database of materials every night. You only want to send the delta, the changes. Change pointers capture these specific changes. How it works. Configuration. 1. Activate globally. Transaction BD61 activates change pointers generally. 2. Activate per message type. Transaction BD50 activates pointers for specific message types. Example. MAT, MAS for materials. DE, BMAS for customers. 3. Define fields. Transaction BD52 defines exactly which fields trigger a change pointer. For example, changing the material description should trigger an IDOC, but changing a non-critical comment field might not. The trigger, when a user changes a field defined in BD52, SAP writes an entry to table BDCP2, change pointer table, a background job runs program RBDMIDOC. This program reads the BDCP2 table, creates IDOCs for the changes found, and sends them to the receiving system. 99. How you handled pricing or partner issues in inbound IDOCs. Scenario 1. Partner mapping issues. The who. The issue. The customer sends their own legacy vendor number, example, vendor 123, in the EDI file to identify us, or they send their internal code for a ship-to party. SAP requires the SAP customer number, example, 1000. The fix, EDPAR. I utilize the IER4 transaction, table EDPAR. This table maps the external partner number to the internal SAP customer number. Mapping, customer CUST01 plus external partner SHIP99 equals internal SAP partner 2000, ship to. If this mapping is missing, the IDOC fails with partner not found. Scenario 2. Pricing issues. The how much. The issue, EDI orders, often come with a net price expected by the customer. However, SAP recalculates price based on condition records. Handling strategy. Approach A. Standard. We ignore the incoming price and let SAP determine the price. Approach B. Tolerance. We map the incoming price to a specific condition type, example, EDI1. We then use a pricing procedure calculation to compare EDI1, customer price, versus PR00, our price. If the variance exceeds a tolerance, configured in PR13. The order goes on incomplete or block status for manual review. Technical check. In the IDOC, pricing is usually in segment E1 ED P01. I check if the VPREI, price, and WAERK, currency fields are populated correctly. 100. Interview question. SD consultant versus technical consultant role in IDOCs. The functional SD role, business requirement gathering, understanding what data the business needs to exchange. Example: we need to receive orders and send invoices. Mapping specifications, creating the mapping document. Excel, that tells the technical team, map the legacy field PONUMBER to SAP IDOC segment E1EDK01BELNR. Configuration, setting up partner profiles, WE20, output determination, NACE, and EDI-PAR or EDSDC mappings. Error handling, monitoring WE02, fixing data errors, and defining business rules for error workflows. Testing, creating test data, triggering output, and validating that the IDOC generated matches the requirement. The technical ABAP or PI role, middleware logic, the PI or PO consultant, configures the translation software to convert the raw EDI file into the IDOC XML format based on the functional mapping spec. Port and RFC configuration, setting up the TCP or IP connections, SM59 and ports WE21. Custom enhancements. If the standard IDOC ORDERS05 is missing a field required by the business, the ABA-PER extends the IDOC, creating a Z segment, and writes the user exit. Example: EXITSAPLVEDA001 to populate that segment. Custom function modules, writing new process codes if standard SAP logic is insufficient. Chapter 18. FSCM Credit Management Internals and Troubleshooting. 101. Difference between FSCM Credit and FIAR Credit Control. Architecture shift. FIAR Credit Management, classic SD credit, monolithic, strictly tied to the sales area and credit control area, CCA, within the ERP system. Table-based, relies heavily on tables KNKK, Credit Master, and S066 or S067, open information structures. Static. Checks are performed directly during document processing using locking logic, which can cause performance issues, table locking, on KNKK. FSCM, Financial Supply Chain Management, Credit Management, Service-Oriented, SOA. FSCM is designed to be a centralized server, part of SAP Credit Management component, that can manage credit from multiple ERP systems or non-SAP systems. Business Partner Driven. It uses the business partner, BP, master data, not just the customer master. Formula-based credit limits are not just manual entries. They can be calculated automatically using formulas: score plus risk class plus country equals limit. Tables uses UKMBP, UKM totals, and UKMITEM. It does not use KNKK. Integration. It integrates with external credit rating agencies like Dun & Bradstreet via XML interfaces to pull ratings automatically. Interview note. In S or for HANA, classic FIAR credit management is obsolete. FSCM is mandatory. This is a critical distinction for an 8-year consultant. 102. What are credit segments and why they exist? Definition. In FSCM, the credit segment replaces the credit control area. It represents a subdivision of a company's credit exposure. A main credit segment, usually 0000, monitors the global credit limit, while subsegments can monitor specific regions or product lines. Why they exist: the business value. Granularity, they allow a company to manage risk at different levels. A large multinational might have a global limit main segment of $1 million for a customer, but limit their exposure in the North American Electronics Division subsegment to $200,000. Mapping You map sales areas to credit segments. Sales area 1000 or 10 or 00, credit segment 1000. Sales area 2000 or 10 or 00, credit segment 2000. Independence. Issues in one segment. Example. Unpaid invoices in Europe can block orders in that specific segment without necessarily blocking business in Asia, unless the main segment limit is also breached. 103. How credit limits are stored and updated. Storage. Limits are stored in the business partner master data, transaction UK MBP. They are stored per credit segment. Technical table UK MBPC MSSGM. Credit management. Segment data. Updates. Manual versus automatic. 1. Manual. A credit analyst goes into UK MBP and types in a new limit. 2. Automatic. The power of FSCM. You define scoring rules and credit limit formulas in configuration. Example formula. Limit equals turnover 0, 20, score or 100. When the business partner's credit score is updated, perhaps via an external rating feed or periodic internal review, the system automatically recalculates the limit. Mass update, transaction UK MMASSUPD is used to recalculate and push these updates to all partners at once. Example. Quarterly reviews. 104. What documents contribute to credit exposure? In FSCM, exposure is categorized by exposure categories. An 8-year consultant must know these categories. 1. Open orders, type 100. Confirmed quantities in sales orders that have not yet been delivered. 2. Open deliveries, type 200. Outbound deliveries that have been created but not yet, PGID, post-goods issue. 3. Open billing documents, type 300. Billing documents created but not yet passed to accounting, rare, but happens if posting block exists. 4. Open receivables, type 200 legacy, now handled via FI. Posted accounting documents, invoices that are not yet paid. In FSCM, this data is pushed from FI-AR to FSCM 5. Special liabilities, special G or L indicators like down payments, can also be configured to reduce or increase exposure. Total exposure calculation. Exposure equals open orders plus open deliveries plus open invoices. Open payments, 105. Real issue. Exposure not updated after billing Y. The asynchronous nature of FSCM. In classic SD, tables S066 or S067 updated immediately, synchronous. In FSCM, the update is often asynchronous, especially in distributed landscapes, or relies on specific events. Troubleshooting steps. 1. WSRM. Web Service Reliable Messaging. FSCM uses internal XML messages to communicate between the SD component and the credit component, even if they are on the same box in S or 4 HANA. If the liability update message fails, exposure won't update. Check transaction SRT MONI SOA monitor for failed messages. 2. UK MTRANSFERITEMS. If the system is not set up for real-time updates, the report UK MTRANSFERITEMS might need to be scheduled to push open items from FI-AR to FSCM. 3. 11 or PI failure. If FSCM is on a separate box, the middleware link might be down. 4. Distribution model. Check if the company code is correctly activated for FSCM updates in the configuration. 5. Rebuild. If data is corrupted, use UKMCOMMITMENTREBUILD to recalculate exposure from scratch for a specific partner. 106. Role of credit representative and workflow. The role, the credit representative is the financial agent responsible for a group of customers. In FSCM, they are assigned to the business partner in the Relationships tab or via the credit segment data. The workflow, DCD, documented credit decision. Blocking. When a sales order fails a credit check, SAP creates a documented credit decision, DCD. This is a case object, accessible via SCASE or UKMCASE. Notification: the credit representative receives a workflow item in their inbox or Fiori Launchpad. Analysis: they open the DCD, which contains a snapshot of the order, the credit limit, and the breach amount. Action: they can release, approve the credit. The DCD updates the sales order status to approved and releases the delivery block. Reject, confirm the block. The order remains blocked or is canceled. Resubmit, ask for more info. Why this matters: this replaces the old VKM1 or VKM3 list processing with a true case management workflow, providing audit trails of who released the order and why. 107. How credit check behaves differently in order versus delivery. Order level check, the promise. Purpose: to prevent the company from committing inventory or production capacity to a risky customer. Behavior: checks the total value of the order plus existing exposure against the limit. If failed, it sets a delivery block on the schedule line or header. Horizon: often checks. Dynamic horizon, example: consider open orders due in the next 3 months. Delivery level check, the execution. Purpose: the last line of defense before goods leave the building. Why check again? Between the time the order was created and the delivery is created, which could be weeks, the customer might have bounced a check or stopped paying other invoices. Their creditworthiness might have dropped. Behavior: if the check fails at delivery, VL01N. The system prevents PGI, post-goods issue. It is generally stricter. Old open orders: the delivery check often includes the value of the current delivery plus all other open deliveries or invoices, but might exclude open orders that are far in the future, outside the horizon. 108. How you debug credit issues using UKMMONITOR. UKMMONITOR is the central dashboard for checking credit check logs in FSCM. The scenario: a user complains order 123 was blocked, but the customer has plenty of credit limit available. Debugging steps: 1. Launch UKMMONITOR. Enter the business partner number and the credit segment. 2. Locate the check log. Find the log entry corresponding to the date or time of the sales order creation. 3. Analyze the rule execution. FSCM uses a check rule. The log details every step of this rule. Step 1. Check static limit. Result: pass. Step 2. Check dynamic limit. Result: pass. Step 3. Check oldest open item. Result: fail. 4. Root cause. The log reveals that while the amount is fine, the customer has an invoice overdue by more than 60 days. The configuration for oldest open item logic blocked the order, not the limit itself. 5. Simulation. You can use the simulation button in UKMMONITOR to rerun the check with hypothetical values to test if increasing the limit would actually fix it. 109. Migration challenges from FD32 to FSCM. 1. Data model mapping. Challenge: mapping the simple credit control area ECC to credit segments FSCM. Solution: careful design workshops to decide if a 1-1 map is needed, or if the business wants to consolidate credit management globally. 2. Master data conversion. Challenge: FD32 data, KNKK, must be converted to Business Partner Credit Management Roles, UKMBP. Tool: SAP provides migration reports, part of the CVI or S/4 HANA Migration Cockpit, to pull KNKK limits and risk categories and populate the BP tables. 3. Open item connectivity. Challenge: in a brownfield migration, ensuring that all existing OpenAR items, invoices, and OpenSD documents orders are correctly transferred to the new FSCM tables, UKM totals. Risk: if this initial load is wrong, every customer will be either blocked unnecessarily or allowed to exceed limits immediately after go-live. 4. Change management. Challenge: users are used to VKM3 and FD32. Solution: training them on UKMBP, UKMCASE, DCDs, and the new Fiori credit management apps. 110. Performance issues in FSCM credit checks. The bottleneck: FSCM requires a call to the credit server, even if internal and often complex calculations involving open items. Common causes. 1. Volume of open items. If a customer has 10,000 open line items in AR, calculating the oldest open item or total exposure dynamically can be slow. 2. Synchronous versus asynchronous. Performing the check synchronously during order save can lock the user interface. 3. UKMCOMMITMENTUPDATE. If the update of exposure is set to run in real time for high-volume order processing, it can cause database contention. Optimization strategies. Summarization. Ensure that credit exposure is updated in summarized tables, UKM totals, rather than calculating from raw line items every time. Asynchronous updates. Configure the system to perform the credit check synchronously, to block if needed, but update the exposure asynchronously, in background, to free up the user's screen faster. Indexing. Ensure proper database indexes exist on UKMITEM for the search criteria used by the check rules. Chapter 19. SAP SD in S/4 HANA differences from ECC. 111. Key SD simplifications in S/4 HANA. 1. Data model simplification, the MATDOC. While more relevant to MM or IM, the aggregation of inventory tables, MKPF, MSEG, into MATDOC improves the speed of ATP, available to promise, checks and inventory visibility in SD. 2. Document status tables removed, VBUK or VBUP. In ECC, status data for all documents, orders, deliveries, billing was stored in two central tables, VBUK, header status, and VBUP, item status. These were massive bottlenecks for high-volume systems. IER4 change. These tables are eliminated. Status fields are moved directly to the respective header and item tables, VBAK or VBAP for orders, LIKP or LIPS for deliveries, VBRK or VBRP for billing. Benefit: reading an order status requires one select statement instead of a join with VBUK3. Business partner, BP, mandatory, customer and vendor master transactions, XD01, VD01, XK01 are obsolete. Everything is a BP. 4. Credit management, FSCM is mandatory, FIAR. Credit management is removed. 5. Rebate management, traditional rebate management, agreement types, VBO1, is replaced by settlement management, condition contract management. 112. Business partner versus customer or vendor impact on SD. The concept in ECC, a customer sold to and a vendor carrier, were two completely separate database objects, even if they were the same legal entity. In IER4 HANA, the business partner is the leading object. Impact on SD configuration and process. 1. Creation. Users no longer use XD01. They use transaction BP. 2. Roles. You create a BP general data, then extend it to specific roles. FLCU00, FI customer company code data. FLCU01, SD customer sales area data. 3. CVI, customer vendor integration. This is the synchronization bridge. When you save a BP in role FLCU01, the system updates the background tables, KNA1, KNVV, so that standard SD transactions, VA01, can still function using the old customer number. 4. Number ranges. A common headache is aligning the BP number range with the customer number range. It is best practice to make them identical. Internal numbering, to avoid confusion. Example: BP 5000 is customer 5000, 113. Changes in credit management. from ECC to S or 4, refers back to Q101 or Q109 but specifically focuses on the what changed aspect. 1. Obsolescence. Transaction FD32 is deleted. Accessing it produces an error message. The tables KNKK, KNKA are no longer updated. 2. Configuration SBRO path. The configuration has moved from enterprise structure, definition, financial accounting to financial supply chain management, credit management. 3. Integration. The link between SD and credit management is no longer automatic based on the credit control area assignment. You must activate the BADI business add-in implementation UKMSD CHECK to connect the sales order save event to the FSCM credit check logic. 4. Functional capabilities. We now have credit cases, DCDs, which allow for storing attachments, notes, and workflows directly related to a blocked order, which was impossible in standard ECC FD32. 114. Output management changes, NAST versus BRF+. The paradigm shift, S or 4HANA, introduces SAPS or 4HANA output management based on BRF+, Business Rule Framework Plus, NAST, Condition Technique. Legacy method, still supported in S or 4HANA but not default for new documents. Uses access sequences and condition tables B001, etc. Configuration in NACE. BRF plus Output Management, Adobe Document Services, ADS, heavily relies on Adobe Forms rather than SAP Script or Smart Forms. Decision tables, logic is defined in decision tables, Excel-like interface, rather than access sequences. Extensibility, easier to add complex logic without ABAP code. Example. If material group is X and customer region is Y, use printer Z. Channels, unified handling of print, email, and XML EDI. Interview insight, be careful. SAP initially pushed BRF Plus as mandatory for billing in 1511, but due to customer backlash, NAST is still fully supported in S or 4HANA for SD. Most clients sticking to S or 4HANA on-premise still use NAST to avoid rewriting thousands of smart forms. A good answer acknowledges BRF Plus as the target architecture, but notes that NAST is still widely used in brownfield implementations. 115. Pricing changes in S or 4HANA, data model, performance. 1. KONV replaced by PRCDELEMENTS. The change. The table KONV, transaction data conditions, is arguably the largest table in any SD system. In S or 4HANA, KONV is replaced by the table PRCDELEMENTS. Why? KONV had a clustered key structure that was inefficient for HANA's columnar storage. PRCDELEMENTS is a flat, transparent table optimized for HANA. Field length. The field for condition currency has been extended, related to multi-currency capabilities. 2. Condition field extensions, access sequences, and condition tables can now handle more fields and longer field lengths. Example. Material number length increased to 40 characters. 3. Pricing engine optimization. The ABAP code for the pricing engine, program SAPLv61A, has been optimized to push calculations down to the HANA database layer where possible, reducing the application server load for complex pricing procedures with hundreds of conditions. 116. Rebate processing removal and alternatives. The removal, standard rebate processing, T-codes VBO1, VBO2, VBO3, and tables like KONA are obsolete in S or 4HANA. The alternative, settlement management CCM, formerly known as global trade management or agency business. Condition contracts. You create a condition contract to define the rebate agreement. Flexibility. Unlike old rebates which were strictly retroactive based on billing volume, settlement management can handle complex scenarios. Vendor rebates. Customer rebates. Royalties. Commissions. Process. 1. Create condition contract. 2. Business volume is tracked, can be based on orders, deliveries, or invoices. 3. Accruals are posted, optional. 4. Settlement run creates a settlement document, which looks like a billing document, to pay out the customer or issue a credit memo. 117. How custom code behaves differently in S or 4. 1. The select trap in ECC, row-based database. Select was inefficient, but tolerated. In S or 4, HANA, columnar database. Select is a cardinal sin. It forces the database to reconstruct the entire row, negating the columnar speed benefit. Custom code must be remediated to select only specific fields. Select MATNR works from. 2. Order by requirement. In ECC, data often came back sorted by the primary key by default. In HANA, parallel processing means data retrieval order is random, unless you explicitly write order by in the ABAP SQL. Legacy code relying on implicit sorting will break. 3. Field length extensions, MATNR, extended from 18 to 40 characters. Custom code that defines internal variables as like Mara matnatnr is fine. Code that defines char 18 will truncate data and cause dumps or data corruption. 4. Obsolete tables, VBUK or KONV. Any custom report reading VBUK directly will fail syntax checks unless a redirect view CDS view is in place, but even then, performance may suffer. Code must be rewritten to read VBAK or PRCDELEMENTS. 118. SD performance issue caused by legacy custom code, how you identified it. The scenario, after migrating to S or 4 HANA, the daily sales report, ZSDDAILY, which used to take 5 minutes now takes 20 minutes. Identification, the toolset. 1. SAT or SE30, runtime analysis. I ran the transaction to trace the execution. It showed that 90% of the time was spent in the database interface. 2. STO5, SQL trace. I ran the trace specifically on the custom program. 3. The finding. The code was doing a select on the table BSID, customer open items, inside a loop of sales orders. Issue 1. Loops within loops, nested selects. Issue 2. In S or 4, HANA, BSID is a compatibility view calculated on the fly from the massive ACDOCA table. Querying a complex view inside a loop killed performance. The fix? I rewrote the logic to use code pushdown. I created a CDS view that joined sales orders and financial open items at the database level and consumed that view in the ABAP program. The report time dropped to 30 seconds. 119. How you decide impact severity in SD incidents, P1 versus P2. The framework, severity is determined by business impact and urgency, not just technical complexity. P1, priority 1 very high or critical. Definition, production system down or critical business process halted with no workaround. Financial loss is imminent. SD examples, no sales orders can be saved globally due to a number range buffer overflow. Invoices cannot be printed or sent to customers. Cash flow stopped. Trucks are waiting at the gate, but delivery PGI is failing for all shipments. Logistics halt. Response, immediate swarming. SLA 1 hour, 24 or 7 bridge. P2, priority 2I. Definition, critical process affected but a workaround exists, or the issue is restricted to a small group or region. SD examples, EDI orders from one specific customer are failing. Workaround, enter manually. Output type ZBA1 is failing, but user can print manually using ZBA2. Pricing condition PR00 is wrong for a specific material group. Response, urgent fix required. usually within same business day, but does not stop the entire business. P3. Priority 3 medium. Definition: single user error, master data issue, or cosmetic bug. Business continues. 120. Most dangerous SD configuration setting you've seen misused. The setting: turning off check credit in the sales document type VOV8 or delivery type 0VLK temporarily in production. The story: a support consultant faced a credit block error during a critical month-end shipment. To fix it quickly, they went into VOV8 and unchecked the check credit flag for the standard order type OR, intending to turn it back on after the order saved. The impact: they forgot to turn it back on for 4 hours. During those 4 hours, automated EDI orders poured in from high-risk customers who were previously blocked. The system accepted millions of dollars in orders from customers who hadn't paid their bills. The warehouse automatically processed the deliveries since the order wasn't blocked. Why it's dangerous: it bypasses the fundamental financial control of the organization. Better approach: release the specific order using VKM3 or the credit case workflow. Never touch global configuration to fix a transactional data issue.